Hello all, welcome to the subject of microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parathipai Ganba, Mojo College of Engineering, Moseley. So today in this lecture, we will going to see about how to interface 7-segment display to the 8051 microcontroller, and we how to write assembly language program for this 7-segment display. So all these things we will study in today's lecture. This is how the 7-segment display will interface to the 8051 microcontroller. Actually, the 7-segment display uses a LED to make any digit. And if all the LEDs are on, it shows the digit 8. And there are two types of 7-segment display are available. One is common anode, another one is common cathode. Let's see. So this is the symbol of the LED. This is the symbol of LED, which is having positive terminal and which is a negative terminal. And this terminal is also called as anode, and this terminal is called as cathode. So to make one complete digit display, so we are going to interface 7 LEDs each other. So there are two ways for connecting LEDs each other. One method is common anode, and another method is common cathode. There are two ways of interfacing LED. First one is common anode, and second one is common anode and common cathode. So what is the difference between each other? We will see what will happen in a common anode. For example, these are the LEDs. See here. See one terminal, the common terminal. This figure is a common anode LED. So here what will happen? For example, we will consider in that all the LEDs are placed. This is one LED, this is one, this is one, this one, this one, this one, this one, which is having two terminals. One is commonly anode. All the anode of the LED is connected to VCC, and all the 7 cathode is connected to port of 8051. So that is called as common anode. For example, these are the 7 LEDs. So assume that these are the 7 LEDs. Common anode is nothing but all the common terminals of all the 7 LEDs which are connected commonly to the VCC, and all the cathode terminal will be connected to the port of the 8051 microcontroller. So this is the main difference. In common cathode, what will happen? All the LEDs are given as a common pin. In this case, the common anode is connected to port pin here. In common cathode, what will happen? Here all these connected common, and all these pins are connected to the port of the 8051 microcontroller. So in common cathode, what will happen? The all the LEDs are connected to ground and all the anode pins are connected to common cathode. In common cathode, all the LEDs in common cathode, what will happen? All the common terminals, cathode terminals are connected to ground and all the anode terminals are connected to port of this 8051 microcontroller. So what will happen if we connected like that? What will happen? To glow the LED with a high intensity, the large amount of current should be provided to those LEDs. And the microcontroller is a source of that to provide a current for those LEDs, which is very large current, but which source cannot be on 2 milliampere. If the source is increases beyond 2 milliampere, and the LED will also be so that what will happen all the we cannot connect directly to the we cannot connect directly so to the all the anode terminal to the port due to and also what we are doing here we are using this circuitry we are connecting the resistor to this VCC. So here what will happen, the voltage VCC is connecting here because to access the high amount of voltage to this LED because this is not sufficient. This what is the current providing with this is not sufficient. So current limiting resistors are also used here. For each pin, each current limiting resistor is connected here. So in between this terminal and here also current limiting resistor is also connected and this is the common anode method. So this is not common cathode, this is the common anode method. So like that, all the configuration will be, we can done. There are two types of 7-segment displays are also available. This is the form of common anode 7-segment display is there. So after interfacing these in a displays to 8051 microcontroller to glow all these the LED. So if we glow all the LEDs, to what will happen? What digit will be displayed here? Here digit 8 will be displayed. 8 will be displayed and name of the each LED will be assigned like that A, B, C, D, E, F, G. So name of this LED will be assigned like that here. So to display the something digit, if we want to digit 1, we have to send appropriate power to these two particular LEDs. If we want to display, so we have to provide a, sorry, if to display 9, we have to provide a current to these particular LED. So it will looks like this. So if we have to display 7, then we have to provide like this. Simultaneously, we have to provide the supply. So how we can manage to display these digit? How we can code this? This will be, let's see. In common anode of all the LEDs are given as a common pin, and in this case, the cathode is connected to the port pin. Hence, the port pins have sink current up to 20 milliampere, and here we use the common anode SSD and connect to the 8051 microcontroller. The 7-segment displays are labeled A to G and DP represents the decimal point, and by forwarding the different LED segments, we can display the digit 0 to 9. Here we can display 0 to 9 here. So the binary and hexadecimal data given to this pin 7-segment display to display the different digits. So what kind of data we are providing from our microcontroller? We are providing binary or hexadecimal data. We are providing to display the digit. Let's see how we can provide the data to display the particular digit. So this is our digit, digital. This is our digit. We want to display. This is the digit. And what type of data we should provide? A, B, C, D, E, F, G, H. Sorry, G. There are 7. These are the 7 LEDs. The name of these LEDs are kept like A, B, C, D, E, F, G, H. Then another pin DP is there. It should be kept high, which What is the function of that TP? I will explain further. So it should be always high. And what data should be provided in hexadecimal form? This is a hexadecimal form code. If you want to send a digit 0, if you want to display a digit 0, then what should we do here? We want to send a code like this. One thing should be kept in mind: to display a different digit, a pin should be given to logic low to switch on the corresponding LED. Here in this common anode, what we should give here, low will be given, then particular LED will be on. The low signal power signal will be given to a particular LEDs, then what will happen? The LED will be glow. In common cathode, high signal we should give. If we are using common cathode instead common anode to glow a particular LED, so what data should be we have to provide? High data will be should be have to provide a appropriate LED. Here we are using common anode connection, so that what we are doing here, we are giving low signal to go glow a appropriate LED. If that signal we have given to, if this signal we have given to our our 7-segment display, so this is hex data we have to give. This is the hex data we have to provide to the 7-segment display to digit to display the digit 0. So what will happen in this term? In this term, see here, this is a 7-segment display organized like this. So this is A and B, C, D, E, F. So what data we should provided to our display? So we have provided low signal to glow. Here common anode, what will happen? At the low signal LED will be glow. So A is 0, A glow, B 0, B glow, C 0, it will glow. This one is also glow, this one is also glow, and this one is also glow. So it will glow and display the digit 0. So 0, Z is high, hence it will not display. So what data will be displayed here? 0 digit will be displayed. Similarly, to display digit 8, we have to provide all the low bit to all the LEDs. To display 3, for example, we want to display 3, then what? Display 3. So what we have to provide? Like this, we have to provide the data to the display 3. See here. What digit is displayed here? Low signal will be digit here. A will be low, it will glow. B will be low, it will glow. And C 0, it will glow. D 0, it will glow. E 1, this will not glow. F, yes. F should be high, means it will not glow. And G is 0 and it will glow. So see here, digit 3 will be displayed. So this type of binary or hex code we have to send to display the particular digit. To drive the multiple segment display, 7-segment display, it is difficult to spare a separate port for each SSD. For the example, interfacing for 7-segment display will be required 4 ports. If we want to display the multiple digits. So I want to display multiple digits here. This is one 7-segment display, and this is 7-segment display, and this is another 7-segment display, and this is another 7. If I want to display the 4 digits, so I have to use 4 7-segment display to digit for particular 7-segment display for particular digit. All the ports of 8051 will be used. In this case, no other device can be interfaced to the 8051 microcontroller. So all the 7-segment display interfaced, interconnected, all 4 7-segment display interconnect each other and connected to the interface to the 8051 microcontroller. Hence, we multiplex the 7-segment display there. Now, to control these 7-segment display, we utilize one of the characteristic of the human eye, that is called as a persistence of the vision. We will give the data for the first 7-segment display and enable its common anode pin, and keeping the common anode pin remaining SSD display disabled. So what will happen here, particularly to display the particular digit of particular 7-segment display, so for that common anode, we are going to keeping the anode high. The other remaining will be low. So a PNP transistor is connected to each common anode pin. Hence, we will provide a 0 voltage to base on this transistor will be turned on, and the corresponding 7-segment display will be selected. For example, for when we give a port to 0 into 07 hex value, the first SSD will be enabled while the other was disabled. Similarly, we will give the data on port P1 for the second SSD to enable its common anode pin, keeping the common anode pin of the others disabled. Keeping the common anode of others was disabled. That can be achieved by giving 0 into 0 B on P2. Similarly for third and fourth also. So entire procedure will be repeated continuously after every 1/15th second of the, or it will be 20 millisecond of the human eye, 20 millisecond delay, so that human eyes can be feel all the SSD to be displaying continuously. So these are the 4 7-segment display have connected into each other, and this is a common anode configuration. All the cathode of these 7-segment display are connected commonly and connected to the port 1 pins, and port 2 pins are using for multiplexing purpose here. Here what LED should be, what 7-segment display should be give like this. So if I want to digit the display single digit from up to 9, I want to display, then this common anode will be on and other will be remains off. So if I want to display 2 digit, then these two will be on and these two common anode terminal will be low. Hence, these two will not turn on. So if I want to display these 3, so 100 digit, up to 100 digit I want to display, then these 3 7-segment display will be on. So these 3 common anode terminal connected high voltage, this one is become low, and such type of multiplexing operation will be performed here by using port 2 pins. If we want to display the 4 bits, so we are going to connect all the common anode pin to high signal. So this type of configuration has been done here. Now write a program to display the message on 8-bit 7-segment LED display, and that is interfaced through port 1 and port 3. We have to display this. The figure shows the 4-digit display, but we have to write a program for 8-bit digital 7-segment display LED, and How to connect a 8051 system using port 1 and port 3. Both the ports are used as a output ports and transistors are used to drive the LED's 7-segment display. So we have to write starting program. So we have to write code move or not, comma, hash 8h. We are going to writing a program for 8-bit LED. So we have to initialize the counter for 8 digits. There are 8 digits we are going to display through the 877 segment display. So we have to initialize our counter using register R0 with a value hash 08h. Then after that we have to write the command move R1 hash 7 FH. This is the pattern we are going to display. So load the pattern into the register R1. So we have to load the starting address from where the message to be displayed. From where the message should be displayed. So that address we are loading into the DPTR. Move port 3, R1. We are going to connect port 3. Each transistor we are going to connect port 3. So we are loading port 3 by the value just a minute. So we have to move the pattern of R1 that we have loaded into we are sending through port 3. Then after that we have to wait for some time. So we are calling a delay. This is the delay. Then we have to write a command move A, R1. So what we have loaded into the R1, we are moving into the accumulator to adjust the select in a pattern, then we have to adjust the pattern by RRA. Then we have to write whatever the data into the accumulator, present into the accumulator, loading back into R1, then increment DPTR. After that, we have to decrement gem non-zero or not, comma, loop 1. The same operation will be performed until the R naught will become 0. We are loading so this is the program for 8-bit 8-digit 7-segment LED display. So we are going to interface these LED to the port 1 7-segment display. We are going to connect the port 1 and the multiplexing transistor which we are using to display the particular digit and to enable the particular 7-segment display, we are going to connect it to port 3 here. This one is 4-bit. Actually, we are writing code for 8-bit. So this is up to 8. So 8 7-segment display will be used, and here the port 3.0 pins are using port 0.7. So we are using transistors because we are having 7-segment display, 8 digit. So 8 7-segment display we are having. To enable those particular 7-segment display, we are using multiplexing purpose. We are using a transistor. So those transistor will be enabled by these 4 pins of P3. So here we have loaded R0 with this 08H, which indicates 8 bits. So we have to set our counter to 8 bit. Then we are moving the 7FH. This is the pattern from which we are going to start the displaying, and we are loading the address from where the message should be displayed. So this is the address. From this particular address the message should be displayed. Then what we are loading, I am loading this to port 3. Port 3 is nothing but after accessing the port 3, it will enable the particular 7-segment display to display the digit. Then after that, we wait for some time, hence L call delay. So after that, moving the accumulator with the R1. So same, we are moving into the R1. Then what will happen here? R command, R nothing but what will happen here? Rotate the 8-bit. Here accumulator what is there? It rotate the 8-bit there. Then move R1 comma A. Again the data whatever it may be there, it will move into the R1. So after that increment the DPTR by 1 and decrement. The same process will be carried out until the R0 should be decrement and that's value should be 0. R0 is 0. Then the return instruction going to be executed. If R0 is non-zero, then it will go to loop again L1. Again it will move to the loop here. Here it will go again L1. Here. So this up to this instruction again, if the R0 is not 0, then it will come to here L1, then start executing instruction repeatedly. So this is the program for interfacing 8 7-segment display. 7-segment display for displaying a digit. Here LCD displays. Now we can see how to interface LCD to 8051. So first of all, see what is LCD. LCD is nothing but liquid crystal display, and the liquid crystal display, they are widely used because of its low current consumption as compared to 7-segment display. Also, LCD can be used to display any characters as it uses a 5 into 7 dot matrix to display. The LCD display can be used to display any character normally which is uses 5 into 7 dot matrix display. For example, display 1 of the LCD. Here, this is a figure shown here. This is the 5 into 7, 5 rows, sorry, 5 columns and 7 rows are there. So, in this manner, the one is shown here. LCD allow the user output a specific message, making the application more user-friendly and attractive. LCD displays are invaluable for displaying the status messages and the information while a program is being debugged. The LCDs are generally use a common controller chip and common connector interface. Due to these factors, the alphanumeric LCDs range in the size from 8 to 80 characters. So all the characters are interchangeable without any hardware or software change. So they are arranged in a 40 by 2 or 20 by 4 or 10 by 2 or 20 by 1 or 20 by 2. The first figure, here this one is a figure, here represents the number of the character in each line. The second figure represents the number of lines the display has. A typical 16 by 2, here typical 16 by 2 LCDs are shown in a figure. Here there are a which is having 16 by 2, 16 columns and 2 rows. So in this structure, this is the structure of 16 by 2 LCD. So LCD pin description, how we can describe the pin of the LCD. Here as shown in a figure which is having 14 pin. So first pin, the pin number 1 is used. The pin number 1 is a VSS which is used for giving a ground connection, and pin number 2 is a VCC which is using for connecting plus 5 volt supply. Then pin number figure 3 VGG power supply to the control contrast, and the pin number 4 RS should be 0 for instructions and 1 for the data. And fifth one is read by W bar. R by W bar is nothing but should be 0 for write operation and 1 should be written for read operation. For write operation, it's a active low signal is there. So if you provide 0, the write operation will be carried out. And pin number 6 is E, which is using for enable the display logic. Pin number 7, which is using for data bus bit 0. Pin number 8 for data bus bit 1 and 8, particular for particular bit. For pin number 6 to 14, we have given there. We have given them bit bus of the 0, first bit of the bus, second bit of the bus, third bit, like that 7 bit. So from 0 to 7, total 8 bits are dedicated for the communication purpose here. So the bit pin number 4 RS is nothing but what? Which should be 0 for the instruction, 1 for the data is nothing but this is the register select bit. There are two registers are there, LCD and instruction command code register and the data register. Because there are two registers are there, one is a command code register and data register. The register select pin is used to select these two registers. If the register 0, RS is 0, then instruction command code register is selected. If RS is equal to 1, the data register is selected, allowing the user to send the data to be displayed on the LCD. So similarly, the read underscore write bar, this pin is used to perform read and write operation. If this pin is equal to 0, the user can write the information. If this pin is 1, the user can read the information from the LED, from the LCD. And the pin E, the pin E is nothing but it can also be denoted by EM. So which is the pin number 6 of the LCD, which is enable pin and which is used to latch the data into the data or common register. When the data is supplied, a high to low or negative edge is required for LCD to latch the data. Here the data from bit 0 to bit 7, the data pins D0 to D7 are used to send the information to the LCD or read the content of LCD internal register. To display the letters and numbers, we send the ASCII code for the letter A to Z and A to and number 0 to 9 while we are making RS equal to 1. We can display the alphanumeric letters, capital letters and small letters from A to Z. And in the numbers 0 to 9 numbers we can display while making RS equal to 1. The ASCII code that is to be displayed, the 8-bit, and it sends the LCD in either nibbles or bytes. So 4 or 8 bytes at the time should be required. The two primary modes of the operation to send the parallel data are 4 into 8 bits. If the 4-bit mode is used, two nibbles of the data are sent to do an 8-bit transfer. The E log is used to initiate the data transfer. So at least 6 IO pins must be available for 4-bit mode. In 8-bit mode, at least 10 IO pins must be used. This mode is used when the application need speed. So the pin number 3, that's named pin number, yes, the pin number 3, that's named BEE, BSS, like that. So these VCC is nothing but provide +5 supply, BSS is nothing but ground. So BEE is using controlling the LCD contrast. So some command should be given to control this LCD, control this LCD. So we have give some command and code to display some particular things in a LCD. The force cursor, home position or blink cursor, like that. So there are a multiple command force for using clearing a display and return cursor, decrement cursor, increment cursor, shift the display right, shift the display left, display off. So there are some particular commands which is in the form of hex command. So we have to provide to perform some these operations like a shift enter display and move cursor to beginning first line and move the cursor beginning second line, initiate line 2 line, display find 7 matrix, and shifting purpose display at the right and shift the display at the left. So to perform some like these operations, we have to provide some hex code. To clear the display command, we have to give the code. First, we have to keep R is equal to 0. R is equal to 0 is nothing but The command port register is selected. Here we are writing the command. So for writing purpose, we have to write RW0. R by W bar should be kept for 0. Then the code 000 up to 1, DB0 should be 1. So it clears the entire display and set the display data RAM to the address 0. So like that, there are many functions. We have to give a particular command. So let's see from the table we can understand easily.